Right, so let's look at another example of calculating an indefinite integral. Sorry, an improper integral. Right, so in this case, the integral we're looking at is the improper integral from 1 to infinity of 2x over x squared plus 9 minus 1 over x. Right, so remember the first step is to express your improper integral as a limit. And so we're taking an integral to plus infinity, so we're taking the limit of t goes to infinity of the usual definite integral of 2x over x squared plus 9 minus 1 over x. Right, so the next step is now to calculate the antiderivative, which in this case is not too difficult. And it's just going to be ln x squared plus 9 minus ln x, 1 to t, and once we substitute it in the bounds, we're going to get ln t squared plus 9 minus ln t minus ln 10. Right. So at this point now you can take the limit. And so if you take the limit here, as t goes to infinity, as ln t, nothing happens to that. Right? That just stays ln t, ln 10. Ln t is going to go to infinity. Right? T squared plus 9 is going to go to infinity, so ln of t squared plus 9 is also going to infinity, right? So we get infinity minus infinity. Right? Now we have to be very careful. This is not 0 necessarily, right? We have to make the calculation. Okay. And in this case, it helps quite a lot if we apply our laws of logarithms right, to these two terms. Right, so that's going to be ln of t squared plus 9 over t, and that again minus ln 10. Right. So now to determine what happens to this term, we have to see what happens to t squared plus 9 over t. Right. We have to figure out what's going to happen to that term as t goes to infinity. Right. Now let's see. As t goes to infinity, what happens to t squared plus 9 over t? Well, this is just t goes to infinity, right, it's going to be t plus 9 over t. Right, so t is going to go to infinity, 9 over t is going to go to 0, so this whole thing goes to plus infinity. Right. So t squared plus 9 over t goes to plus infinity as t goes to infinity. So ln of t squared plus 9 over t is also going to go to plus infinity. Right. So what can we say about our original integral k? Well, this term goes to plus infinity. That stays ln 10, so the whole thing is plus infinity. Right. The integral is divergent. Right, remember, this integral is convergent if the limit exists as a finite number. And in this case, we've shown that the limit is plus infinity, so the integral is divergent. So, again, let's just go over the pressure points, places where things could go wrong. Right, firstly, you have to express your integral as a limit. If you don't do that, your calculations aren't valid. Right. Secondly, calculating the antiderivative, not too difficult in this case. And now here's where it gets tricky, right? We get infinity minus infinity, right? Which isn't necessarily 0, it isn't necessarily infinity. It could be a finite number. We have to do the calculation to see what happens. Right.